Good morning, everyone, and welcome to today's webinar, Maximizing Payload on Alternative Energy Vehicles. My name is John McLean, and I'm a Sales and Marketing Executive at TruckScience. So I'm going to dive straight in here. So EVs and other alternative energy vehicles have been around for a few years now, and the trucking industry has invested heavily in these technologies. Because of the complexity of the industry, however, with all of the different applications commercial vehicles are used for, there's still work to be done around infrastructure, range, engine power, and more. In this webinar, however, we'll focus on some of the weight implications using these new technologies. And we'll be using two real-life examples to illustrate common scenarios where EVs are currently in use. We opted to go for two EVs rather than, say, a CNG example, as the overwhelming majority of inquiries we receive are about EVs. Depending on demand, vehicles using other energy sources could be a subject of a later webinar, and you can let us know that if you'd like to see it. Let's get started. First up, will be a Peterbilt 520 EV with a garbage body, followed by International EMV with a refrigerated body. So I'm just going to flick over to the TruckScience app here so we can dive deeper into these examples. Okay, so as I mentioned, we'll first design a garbage truck operating in California. So what I need to do is I need to set up these regulations to validate against that. So if I go to my settings wheel and I go to where our regulations applied, I can clear this filter and I will put in California, state roads. And just to mention, all 50 states are catered for at an interstate level, and a lot of states are catered for at a state road level. We're constantly adding new ones on request. And we have also released the Canadian provinces. It is also possible to pin attributes of the vehicle that you might be interested in. In this case, I've pinned. Let me see here. I've already pinned. I've flown past it there. The gross weight on the vehicle front is a percentage, and also the utilization, the vehicle gross as a percentage of GVWR, and also as a percentage of the permissible. So I'm going to be using those later on, so I'll keep that the way it is. But I'll also mention here in organizational standards, we can also define ranges for particular attributes that our organization is comfortable with. So for safety and traction, we might have an internal limit we adhere to on, say, the gross weight in the vehicle front, where we could limit that between 20% and 50%. And I'll leave that the way it is now, and we may get to that later also. So I'll just click OK for that. So as I mentioned, so now we will select our vehicle from our database of OEM specs. So I said that we go for a Peterbilt, 520, 6x4, and I'll go for this EV spec. Okay, so now that we've the vehicle loaded, let's familiarize ourselves with the workspace. So straight away, we can see that we have a notification that our front and rear chassis weights of the default spec have not been provided by the manufacturer. Some provide the weights on their bodybuilder portals, which we then include in the software, while others prefer you get them directly from the dealer. We cater for either scenario, but I'll just go ahead and input these weights now. So for the front axle, I'll give it a weight of 14,200 pounds. And for our rear axle, I'll give it a weight of 8,300 pounds. Okay, so you'll notice that the weights are quite a bit heavier than the equivalent diesel spec. And we'll see how that impacts the overall payload later. I have another notification here that the vehicle has an additional 2,000 pounds allowance in California because it is a battery electric spec. And I can see that this has already been applied to the vehicle's total permissible here. So for diesel powered vehicles, the limit is 50,000 for this particular overall bridge distance. We can see here we have 52,000 now. Just exit out of that. So apart from the weights table on the right-hand side, of the dashboard. Other items that we can note here are just the compliance indicators. So these give us the visual feedback on whether our design complies with what we call our three pillars of compliance, which is the manufacturer's limits, the regulatory compliance, and organization standards. So the organization standards are internal quality or safety standards that are not enforced by law, but are nevertheless desirable metrics to implement on a build. So as expected, we've all green ticks here for the default spec. So we can also see the data points we pinned earlier here just below. So on the far left-hand side here, we can see that we can drill down to add our vehicle bodies, our equipment, and also our payload there. On the right-hand side, we can see we can toggle between different views. Sorry, I'll just X out of that. So we've got our bridge view, our center of gravity views, and also our turning radius views. Okay, so the turning radius data has also not been supplied by the OEM on their bodybuilder portal. So I'll also add this as well. So we'll use it later on. So I'll add in from the spec sheet. So our track width on the front there, I'll go for 83 inches. And also the turning ability, our inner steering angle of 40 degrees. And there's populate. And we'll get back to this later on. I'll just go back to my side view and we can start adding a body. So now since this is a vocational truck and we don't have a traditional PTO from the transmission, we might need to add an ePTO to power the garbage body that we're planning to add. So the chassis provided by the dealer might well come with this pre-installed, but I'll add one for our example here using a template. So I'll go over here to my equipment, and if I go down to, sorry, that's body, go down to equipment, and you can see a whole different ranges of equipment there, go down to other, and I'll add in our equipment template. I'll also give it some dimensions. So our length, I can change to 16. Our height, I'll give that 27. And our width, we'll go for 20. We'll also change the weight to 250 pounds. And we can position it here by dragging and dropping it. But just to make things a little bit more precise and easier on my end, I'll add in here on our position tab. So we'll go for 27.6 inches from the back of the cab, and above, so below the chassis, I'll go for minus 27.6 inches also. Okay, so if I had a DXF drawing of my ePTO, I could also have imported that to make the drawing more realistic. But by using a template, this gives you perfectly accurate results if you populate that data correctly. So now I'll go ahead and place that on the chassis, which has been done. Yes. So yeah, now I'll add my body, sorry. So I will actually be able to add a DXF drawing that I've prepared earlier here. So you'll be able to see that in the example. So I'll go for my garbage truck under add body, and I'll go for import DXF. Choose my file that I have here. Okay, so I just need to input some data here. So I'm just going to drag this down onto the XY axis so it imports correctly onto our drawing. So our length, we're going to give this a length of 279.6. Our height is auto-scaled according to the length, so we won't need to adjust that. Our width would be 96 inches. And so next we'll put in our weight. Our body weight will be 14,700 pounds. Our horizontal center of gravity, we'll put that in inches just so you can see that. So we'll go for 151 inches. And then our vertical center of gravity, we'll put that at 30 percent. And our lateral CG we'll keep at 50. And our payload CG, I'll put that in inches as well. And we can put that at 103.5. And we'll click next here again. And we'll save this as a sample uh, and save and add that to our body or to our chassis. Now I'll just go back full screen. Okay, so now let's take a look at our weights table again here. So we can see from the weights table here that our front axle is fully utilized and that we have some excess capacity on our rear axle and on the overall. So let's drag that body back just a little bit. But before I do that, just note the payload there is just under 14,000. So we'll drag it back just a small bit. Okay, so we can see then when we drag the body back, it jumps up by another 4,000 or 400 pounds or so. And now that fully utilizes the extra 2,000 pound capacity allowed for EVs in California. So that ends up being quite a respectable 42,863. Oh, sorry, reading the wrong one. Uh, sorry, I didn't realize the body jumped there. I'll drag that back this direction. Apologies. Actually, something I can just do here, make my life a little bit easier. I'll press the undo button. Yeah. And there we can see now our payload is a respectable 14,350 pounds. So up to now, we've been auto-calculating the maximum legal payload. So as an experiment, something we could do is lock the payload and see what happens if we move that body away from its position. So I'll just lock that payload, click out of it. And if we drag it from away from its position, you can note that the vehicle is becoming overloaded, as indicated by our compliance dashboard. So either direction. And again, I'll just undo that change. So undo that. Okay, so one thing we need to do now for sure is since that body is on, we need to reduce that after frame. So I'll just go ahead and do that. So I'll click in here to my after frame and I'll bring that down to 56 inches. So it's more suitable for the body. And I'll also update this cab to body, just which is specified by the manufacturer, to 45 inches. Okay, so now if we look at the data points that we pinned earlier down here, we can see that we're at full utilization on the permissible, but that we have some excess capacity on our GVWR. So let's go ahead and just unlock that payload. It may be unlocked already from me undoing that. Yeah, it's already unlocked. Um, and now we can see uh, what the impact is of changing, say, regulations to something less restrictive like a state, say, like Colorado. So I'll just go ahead and select Colorado instead of California. So just keep an eye on that payload down there as well. So we're at 14,350 pounds. So I'll clear away California and I'll put on Colorado, state, roads. Okay, so we can see there immediately that jumps up to over 9,700 pounds. But again, we can see that that the front axle is still the limiting factor, indicated by the 100% utilization of the weights table. So if we move the body towards the rear again, so I'll just move that a small bit here. Oh, sorry, that is jumping a little bit on me. Okay. So if we move that towards the rear again, we can see there now we've got another uh, 2,000 pounds additional payload. So this additional payload is freed up because we're utilizing more of the vehicle's GVWR here. You see that's gone up now to 87%, um, to take advantage of Colorado's more generous allowance on the rear axle of 40,000 pounds as opposed to 34,000 pounds in California. So moving the body, though, towards the rear to gain more payload does not necessarily make operational sense, though, as this will increase the vehicle's swing out, which could become a safety issue in residential areas. So again, I'll just undo that. I'll just bring that in a little bit. But something else we could think of as well, because this vehicle is operating in residential areas, it also needs to be maneuverable. So having a small turning radius is desirable. The shorter the wheelbase, the smaller the turning radius. But the shorter the wheelbase, the smaller the weight allowance we'll get on bridge. So we populated those details earlier there in our turning radius, but it's a little bit of a trade-off here. So in this case, we're prevented from reducing the wheelbase any further because of the location here of the batteries. And this can often be the case with EVs. So if we're happy with this vehicle at the end of our build, we can, or at the end of our configuration, we can actually export our PDF. Which will contain multiple views and your different notes and warnings. You've got your top view, your side view, your turning radius view, and also all different notes and warnings are there as well. And that's actually coming to the end of my first example there. Martin, if there's any questions that have come up that maybe we could field.
Thanks, John. There are no questions at the moment. So just a reminder, please feel free to use the Q&A feature to ask a question, even if it's slightly unrelated to what John is presenting here. And I'll do my best to answer those questions for you. And we can also take questions offline if we don't answer them in this session. Thanks, John.
Yeah, perfect. Yeah, of course, feel free to ask any questions with that Q&A feature. So I will move on to my second example. So I'll just go back to the home here and reset everything. So for our next example, we'll design an all-electric refrigerated truck for use in California. So I'll switch back to the Californian regulations here. Where state. And I'll leave these favorite measurements the same way they were, and also the organization standards, as they will be relevant for this build also. So we'll start by selecting our vehicle, which will be the International EMV 4x2, and we'll go for this one with the 217 wheelbase. So this one has a battery capacity of 210 kilowatt hours and an overall weight of just over 14,000 pounds that you can see there. And we have a note again that about that additional 2,000 pounds overall bridge allowance for EVs. So this vehicle, however, will be limited by the gross vehicle weight rating of 33,000 pounds, and will not be able to take advantage of the 2,000 pounds overall bridge allowance. To confirm this, we can drill down here to the overall permissible. And we can see that the gross vehicle weight rating is 33,000 pounds and the bridge limit is 42,000 pounds. And therefore, the lesser of these is 33,000 pounds for the permissible total. So this vehicle will, however, be able to take advantage of axle allowances that apply in certain states. And I'll come back to that in a little bit. just remove that example. So as I did with my last example, I'll add a body here as well. So if we go to add a body, I'll go for a box template here, and I'll just drag it back very slightly, and I'll actually put that at 4, not 4.1. Um, and what we can do here, so let's say our customer needs a 20-foot body, so we could change this length to 240 inches here on the body lengths, and we can also align that with the chassis by clicking in on the body here. So we said this would be a refrigerated truck, so we'll need a refrigeration unit. So we'll go back to our equipment here. We'll go for a refrigeration unit. We'll select a Thermo King, and we'll go for an E1000. So this unit will be easy to integrate with the battery of this vehicle to give us an all-electric solution. It also weighs about 200 pounds less than the equivalent diesel-powered version, so there's also a saving there. We might have enough clearance above the cab there, but we could do with a bit more body height for our load. So let's increase the body height here as well. So we'll go for 100 inches. Okay, and then to complete our configuration, I'll add a lift gate on here. I'll go back to our equipment, to our plus sign. I'll go for a lift gate, and this time I'll go for a Maxon um, TE33. Okay, and we have a whole other list of options available there. So now that our configuration is complete, we can take another look at that weights table. So we can see that the app has calculated the maximum payload for this vehicle in California to be about 9,500 pounds, which is highlighted in blue here. The other figure highlighted in blue is the utilization on the rear axle, which is currently is at 100%, and therefore the limiting factor for this calculation. So due to the relatively heavier rear axle weights on EVs, this is quite a common scenario. So this is why some states like Arizona have started allowing the additional weight to be spread over axles for EVs, in addition to the overall allowance. Let's try switching to Arizona actually to see the impact that this has. So again, just keep an eye on that payload, and I'll go back to our settings. I'll remove California and add in Arizona. Okay, so the effect we have there is an increase in about 1,000 pounds on payload, which is now increased to 10,500 pounds. So this is because Arizona also applies the 200 or 2,000 pound allowance on the axles. This allowance can be applied to either front or the rear axles or split over both. If we drill down on the rear axle here, sorry, that's the front axle. So we can see that the allowance has been applied for the rear axle by default, which is now which now has a bridge limit of 22,000 pounds. However, since the gross axle weight rating is limited to 21,000 pounds, we can only take advantage of a 1,000 pound allowance here. So just remove those. So the rear axle is still our limiting factor, but but we have 2,000 pounds there of unused capacity on the front axle and also on the overall. So to achieve a better utilization of the front axle, we could consider a few options here. So one of them would be to load heavy items up front and lighter ones to the rear. Another would be a longer wheelbase. And a third option would be a shorter body that would result in the payload center of gravity moving closer to the front axle. So let's try the third option there, of reducing the body. So I'll reduce it from 20 feet to 18 feet. So for this change, I'll change the length to 216 inches. It's 15, 16. Okay, so we can see here that that gets us an extra 1,500 pounds, and our payload is now just over 12,000 pounds. With the utilization of the front axle, utilization of the front axle now at about 90%. So this gets us reasonably close to what we would achieve with an equivalent diesel powered vehicle. Again, if you're happy with this drawing, you can go to your PDF and you can generate your report. And that's actually coming to the end of my second example there. Martin, have there been any questions since?
John, there are still no questions.
Okay.
So yeah, feel free to still post your questions there.
Mhm.
Otherwise, John, you can probably wrap it up then with the slides if there are no questions. But I'll still keep an eye on the questions in case somebody has a question last minute.
Yeah, perfect. Yeah, I'll move over to my slides, but please do feel free to ask a question, and we can always come back to the app and answer any questions that we need to then. Okay, so I'll just flick back to my slides. Okay, so to sum up, here are a few things to consider when upfitting and utilizing EVs. So to start with, the regulatory allowances for EVs vary significantly between states. So the jurisdiction where your vehicle is used is very important in the design process. While states like Arizona already allow more weight to be spread over the axles as well as overall, upping the allowance over the axles even further would make EVs more competitive in terms of payload carrying capacity. So while payload is not the only consideration, it certainly is an important one. So secondly, the vehicles are generally heavier than their diesel counterparts. So batteries are often spread across the chassis rail, moving the center of gravity further back, using up more of the rear axle weight allowance, as we saw in our second example. With the batteries being spread across the chassis rail, there is less space to play with for possible wheelbase and afterframe alterations. So the less space to mount auxiliary equipment and bodies. And finally, without the traditional PTO from the transmission of the diesel engine, we may need to cater for an EPTO when speccing vocational vehicles. This also has an impact on weight and chassis rail space. Um, so I've used the TruckScience Axle Weight Calculator to work through two examples today. If you'd like to try the app yourself, please visit truckscience.com to register for a fully functional 7-day free trial. You'll be up and running in a few minutes. And just before I wrap up fully there, Martin, I'm just double checking there's no questions.
There are no questions at the moment, John. Oh,
Okay.
yeah. Okay.
Okay, perfect. So I will end this webinar shortly, but before you go, please do rate the webinar and leave any comments or questions you'd like to share with us. If you'd like to set up a personalized demo of the app, just leave your contact details in the comments and we'll gladly set that up for you. Thank you very much for joining us today, and we do look forward to your feedback, and goodbye.